So this first one is asking for an absolute maximum on this interval. So that is the candidates test. And the candidates for your absolute maximum are your endpoints, so these two values, and your critical points. So we're going to start by doing derivative equals 0, which is how pretty much all these are basically going to start. So this will be 3x squared minus 6x equals 0. And we'll factor out 3x. We'll be left with x minus 2. And so we get 0 and we get 2. And so our candidates are -2, 4, 0, and 2. And so I'm going to put them in a chart, and we're going to plug into the original function. So make sure you plug back into this. And I like to put them on there in order. You can put them on in whatever order you want, but I like to go numerically. All right, so let's plug these in. -2 cubed would be -8. -2 squared would be 4 times 3 would be 12, so -12, and then +12. So those cancel, and we get -8 for that one. If we plug in 0 for all these x's, we're just going to get 12. And then 2 cubed is 8, minus 12 plus 12, so that's going to be 8. And then for 4 cubed is 64. Minus, all right, 4 squared is 16 times 3 would be 48. And then plus 12. All right, let's see. -48 plus 12, that would be -36. So we're going to do 64 minus 36. And if you don't have a calculator, you have to, get through this somehow. Count on your fingers, write it down, whatever you need to do to get that result. So these are the outputs that we got from those, and we want the absolute maximum. Now they don't ask for the maximum, so they don't want the 28. That's the biggest one we got. It says occurs at x equals. So the x value where that happens is 4, and so that one is A. All right, this one, I know I'm going to need a calculator for this because I see all these decimals. It says the first derivative of a function is given by this. That's good that we're given the derivative because that's what gives us all the information. It's the first derivative test, right? So it says on what intervals is the function increasing? All right, that is going to be where the derivative is positive. So we're going to take a look at this derivative and see where it is positive. So if you want to follow along in the calculator with me, you can. We're going to go to y equals. And we're going to type in this function. So sine of x cubed minus x. So sine of x cubed minus x. And then we're going to go to window. And we want to make the window be what we're given, which is 0 to 2. For the y's, I'm just going to leave it standard to start out with, but we may need to change that. So let's just wait and see what it looks like. And then we'll think about if we need to change that interval. Yeah, I'm going to need to change that. There's all this empty space and I need to bring this in. So let me make it, instead of -10 to 10, let's maybe make it like -3 to 3 and see if that's a little bit better. And I don't have real specific instructions for this, like finding that window. You kind of just need to mess with it until you're happy. So that looks a little bit better. I can see that better. So we're looking for where this derivative graph is positive. That would mean above sea level. So it's from 1, and our interval here is 1 to 2, or 0 to 2. So this is 0, this is 1, this is 2. So we're above sea level from 1 until like somewhere like 1.6 or 1.7. You can calculate this precisely if you want to, but the AP exam is timed, and if you have choices, I would just look through them. We're looking for one that's from about 1 to about 1.6 or 1.7. So when I look at these choices, that looks like B. And if you were to calculate that 0 specifically, you would get this 1.691 and then more decimals. But again, if the AP exam is timed, you don't want to take time for that. Just use the choices to help you. All right, here again, we're given the graph of the derivative. That's good because that's the thing that gives us all the information. It's the first derivative test. All right, and then they're asking about the relative extremes, so maximums and minimums. So these are our 3 critical points that we need to look at. And so let's label them either as a relative maximum or minimum. At this one, our derivative changes from negative to positive. So it's below to above. So negative to positive means that's the location of a relative minimum. And then the same thing is happening here. We have negative to positive. So this would be the location of another minimum. And then this one, we have a change from positive to negative. So that would be the location of a relative maximum. So we have one relative maximum and two relative minimums, which is choice A. All right, number 4, a function is given by this. We want to know where we have a relative maximum. Okay, so it's exactly the same question as number 3, really. We're looking at the relative maximums and minimums, but instead of just being given a graph of the derivative, we're given this equation. So we're going to have to find the derivative, set it equal to 0, get all the critical points. Like we're going to have to actually do the work for this one. All right, so this derivative will be 15x to the 4th minus 12x squared minus 3. I'm going to set that equal to 0. I'm going to divide everything by 3 just to make these numbers a bit smaller. So this will be 5x to the 4th minus 4x squared minus 1. And then we're going to split that. Now I know it's usually you have an x squared term and then just an x and then just a constant. This time it's to the 4th though, so when we split it, it's going to be 5x squared and 1x squared. It's the same exact concept, it's just we have a squared instead of just an x. And then 1 is going to be 1 and 1. And to get negative 4 in the middle, we'll need negative 5 and then plus 1. So this factor is not going to split any further, but this one is a difference of squares. So that'll split x plus 1, x minus 1. All right, so we have our derivative, we have it all factored, and we're going to make a number line for each one of these factors. So the 5x squared plus 1, the x plus 1, and the x minus 1. So this is not going to give us a critical point. If you set this equal to 0, you're going to end up trying to square root a negative number. So there's no critical point that's going to end up on here. And this is just going to be positive the whole way across. No matter what number you try to plug in, if you square it, it's going to be positive. And if you multiply that by 5 and add 1, it's still going to be positive. So it's just positive the whole way across. X plus 1 is going to have a critical point at negative 1. X minus 1 is going to have a critical point at positive 1. And these are both going to be negative until they get there and then turn positive. And you can pick test numbers to check that if you want to, but nothing weird happened. It wasn't backwards or anything. There wasn't a squared or an extra negative. So it's going to be negative and then turn positive. And so we've sliced our number line into these 3 sections. The first section, we have a positive times a negative times a negative. So negatives cancel. The overall sign is positive. For this middle section, it'll be negative. And for the third section, it'll be positive. And so this was asking where we have a relative maximum, that would be where the derivative changes from positive to negative. So from positive to negative happens right here. So at x equals negative 1. And so this one is A. All right, number 5, again, we're given the graph of a derivative. That's good. We want to know where f is increasing. So the function is increasing where the derivative is positive. So that means above sea level. So that would be from negative 2 to 3. And so that one is B. All right, for number 6, we're given the derivative, but this time it's an equation, not a graph. It says at how many points will the graph have a relative maximum? All right, this is the same exact thing that we did right here. It's just we don't have to actually take the derivative and factor it all apart because they gave us the derivative. So it's going to be exactly what we did here, except we don't have to do this work. We're going to be able to just go ahead and do the number line because this is the derivative. So we don't have to find the derivative because they gave it to us. So we're going to make a number line for x to the 4th and a number line for x minus 2, and a number line for x plus 3. So this would equal 0 at 0. This would equal 0 at 2. And this would equal 0 at negative 3. And once again, just notice I put them on there going left to right like a number line. So, smallest to biggest. Now, x to the 4th, since that's an even power, no matter what number you plug in, this is going to be positive all the time. Any even power, like squared or to the 4th or to the 6th, that's going to be positive all the time. And then these two, there's nothing backwards or negative or squared, nothing weird. So they're going to be negative and then turn positive. And again, you can always pick a test number to plug in to double check that. And so once again, we've sliced up our number line. Well, actually, I guess I don't really need to slice this at 0 because there's not a change there. You can if you want to. You know what, I'll go ahead and do that. So this first section, negatives cancel, that will be positive. This section will be negative. This one will also be negative. And then this one will be positive. So we're asked at how many points do we have a relative maximum? So once again, that's derivative changing from positive to negative. And that happens right here, positive to negative at negative 3. Now, negative 3 is not the answer, though. They just said at how many points? And there's only one time that that happens. So just one, so B. So that's tricky. They didn't ask you for the answer, just how many answers are there, which is weird, so just be careful. All right, so number 7, again, this is the graph of the derivative, which is great. The derivative is what gives you all the information, so that's the one we want. And then it says, what statement is true? And then they give you all these statements about increasing, decreasing, and minimums and stuff like that. So here's what I would suggest. Don't look at the choices, because 4 of them are wrong, okay? Let's write out what we know about this. F of x is increasing where this derivative is positive, so above sea level. So that would be negative 2 to 0. And f of x is decreasing where this graph is below the x-axis. So that would be from 0 to 2. And this is our critical point. We have a change from positive to negative. So that means a relative maximum at 0. So I would list out what you know and then go and read the choices and see which one matches up with what you said. And it's going to be this one. Function is increasing from negative 2 to 0. Let me address E though really quick. It says F is not differentiable at negative 1 and 1. I do see we have sharp edges there, but this isn't the graph of F. This is the graph of F prime. So if that said F prime is not differentiable, then that would be true, but it says the graph of F, which isn't this graph. We don't have the graph of F. I don't know what that looks like. So just remember, you're answering questions about a graph that you're not looking at. So just be careful. This is the derivative graph. All right, and then last one, what are all values of x for which this function is increasing? So again, increasing means derivative is positive. And so we're going to need to get the derivative, get the critical points, make a number line, see where it's positive. Now, what derivative rule are we going to need for this? Because I have this stuff in parentheses, and then I have it multiplied by something else. So what derivative rule is that going to be, guys? Since I have 2 functions there. Good, nice job. Thank you. Yes, good. Product rule. All right, so product rule is the first function, so the x squared minus 3, times derivative of the second. All right, that's itself. It'll be e to the negative x. And then you have to chain on the derivative of negative x, which would be negative 1. So I'm just going to put a negative with that. So it was a chain rule. So first times derivative of the second plus the second times derivative of the first, which would be 2x. And so we're going to need to factor this. There's really only 2 terms. This is the first term, and this is the second term. Whenever you do a product rule, you only get 2 terms. It's all of this plus all of this. So I'm going to factor out a negative e to the negative x. So that's going to be our greatest common factor. So if I take that out of the first term, I'm just left with x squared minus 3. And if I take that out of this term, I have the e to the negative x. Oh, sorry, I forgot the negative there. I have the e to the negative x, but I'm also dividing by a negative. So that's going to make this plus into a minus. And then I've got the 2x that's there. And so in this next step, I'm just going to rearrange this so that it's in descending order to make it look a little bit nicer. This would be x squared minus 2x minus 3. If you don't need to rearrange that and you're comfortable looking at it how it is, then you can skip that step, but I just rewrote it so we can see it's a trinomial, and then we're going to split that apart. I'm forgetting to write that negative. Stop that. All right, and so this is going to split x minus 3, x plus 1, and I can make my number line. So these are my 3 factors I'm going to use to make the number line. So this is going to have a critical point at 3. Whoops. And this is going to have a critical point at negative 1. Again, I put them on there in order. This is not going to have a critical point. E to the x is a swoop. It's never going to touch 0. So this is either going to be positive all the time or negative all the time. And we've reflected this swoop over the x-axis. It's going to be below sea level. So this is going to be negative all the time. Also, you can plug in any number you want to check that, and you'll get a negative result. All right, and then these other 2 are going to be negative and then turn positive. And so I'm going to slice up the number line here. And we have negative times negative times negative. So that'll be negative. Here we have 2 negatives, they cancel. So positive, and then this section will be negative. And we were asked, where is the graph increasing? So we want where the derivative is positive. So that's going to be this middle section. So negative 1 to 3. And so that one is D.